Welcome. In this module, we will explore the foundation of the Microsoft Azure platform, the physical data center. We will examine the physical infrastructure, power, cooling, and networking components that enable the cloud services you rely on daily. Let's get started. To understand Azure, we must start with the physical reality. An Azure data center is a physical facility, conceptually similar to a large corporate data center you might manage yourself, but on a massive scale. Inside these facilities, computing resources are arranged in racks. Crucially, every data center is equipped with its own dedicated power, cooling, and networking infrastructure to ensure continuous operation. Microsoft manages these facilities entirely, handling all physical maintenance so you can focus on your applications. This mind map breaks down the core definition. At the center is the Azure data center. The top branch highlights it as a physical facility that is secure and managed by Microsoft. The bottom branch details the infrastructure, showing that it contains server racks supported by dedicated power, cooling, and networking systems. This visual establishes the data center as a self-sufficient unit. Let's zoom in to the rack level. Inside the data centers, resources are arranged in racks. When you request resources, Azure creates virtual machines based on your specific needs. These VMs run on a specialized Azure hypervisor. It is important to note that while you interact with the VMs, the hypervisor itself is designed strictly for cloud use and is not accessible to the public. This separation ensures the security and integrity of the underlying platform. This diagram visualizes the stack within a rack. We see a server hosting multiple virtual machines. Beneath them sits the Azure hypervisor, highlighted in pink, which acts as the foundation. The dotted line from public access blocked to the hypervisor illustrates that while you use the VMs, the hypervisor layer remains inaccessible to the public for security. The network within an Azure data center is structured in tiers to ensure efficient data flow. As illustrated in the diagram, it starts at Tier 0, which is the networking at the individual rack level. These connect up to Tier 1, which aggregates the network traffic for a row of racks. From there, traffic flows to Tier 2, which handles networking for the data center. Finally, this connects to regional gateways, bridging the internal data center network with the outside world. This flowchart shows the vertical hierarchy of the network. We start at the bottom with Tier 0 at the rack level. Data flows up to Tier 1 at the row level, then to Tier 2 at the data center level. Finally, the traffic exits through regional gateways to reach the wide area network. This tiered approach organizes connectivity efficiently. Reliability is built into the network architecture. The bars you see in architectural diagrams often represent groups of network devices rather than single units. This grouping provides redundancy at every tier we just discussed. If one device fails, others in the group take over. This design not only ensures high availability, but also supports high bandwidth connectivity, allowing massive amounts of data to move rapidly through the data center without bottlenecks. Here we visualize redundancy. We have a Tier 2 group and a Tier 1 group, each containing multiple interconnected devices. The arrows connecting the groups represent redundant paths. This shows that if device A fails, device B can still handle the traffic flowing to the Tier 1 group, ensuring the network remains operational. Azure data centers do not operate in isolation. They are integrated into a massive wide area network, or WAN. Regional gateways act as the bridge, connecting the specific data center's Tier 2 network to this global WAN. This architecture allows Microsoft to manage a cohesive network of data centers, providing the infrastructure you need to build, deploy, and manage applications and services that can reach users anywhere in the world. This diagram illustrates the global scale. We see 3 distinct data centers on the left. Each connects individually through a regional gateway to a central node representing the global WAN. This visual emphasizes that while data centers are physical locations, they are all part of one interconnected global network. Finally, let's discuss security and management. The Azure Production Network is physically separate and strictly managed. Microsoft handles all operations and maintenance, employing rigorous physical security measures to protect the facilities and premises. As mentioned earlier, key components like the hypervisor are designed for cloud use and are not accessible to the public. This ensures that, while you have control over your virtual resources, the physical and platform security remains under Microsoft's tight control. This class diagram separates responsibilities. The top class, Microsoft Responsibility, includes physical security, hardware maintenance, and power and cooling. A protection layer separates this from the customer view, which contains your VMs and applications. This demonstrates the security boundary where Microsoft secures the physical facility, isolating your resources from external physical threats. In summary, Azure data centers are the physical foundation of the cloud. They are secure facilities with dedicated power and cooling, organized into a hierarchical structure of racks and rows. Their network architecture relies on tiers of devices to provide redundancy and high bandwidth, connecting seamlessly to a global wide area network. Managed entirely by Microsoft, these data centers provide the secure, reliable infrastructure required for your cloud applications. Our final mind map consolidates the key takeaways. The central node Azure Data Center branches into three pillars: physical, facilities and racks; network, tiered architecture and WAN; and security, Microsoft management and restricted access. This provides a complete picture of the data center's core architectural components.